Alright, so in the previous video we calculated the left-hand sum using using four equal width intervals. In this video we're going to do the same thing, but we're going to do the right-hand sum. So let's just jump right into it. And I want to go again from 0. So I want to go again from 0 all the way to when x is equal to 1. So I'm looking again at this region right here, and we're going to be doing this using four right-hand approximations. And just recall that delta x, our delta x, is equal to, again, where we end, and we're ending here at 1, so it'll be 1 minus 0, where 0 is the starting position here, and we're going to divide that by how many subintervals we want. So we want 4 subintervals, so that'll be 1 over 4. So that means that when I cut this thing in half here and then in half there, there's my four subintervals. That this will be 1/4, this will be 1/2, and this will be 3/4. And again, each of width 1/4. So now I'm ready to go ahead and start drawing my rectangles here. So again, a right-hand approximation means that instead of making my rectangle start here, I will now draw my rectangle on the right side and kind of make this little rectangle right here. So that's pretty good. And then if I continue doing the same thing here, now I'm going to use the 1/2 here. I'm going to use the right side of the rectangle to touch the curve, and then I'll go over a little bit to the right just to make this rectangle there. And then finally, or not finally, but we have 2 more rectangles to go. We have this 3/4 here, so there we go. So there's my rectangle right there. And finally, the last one that we have that I'll do, let's see, I'll do that in red here. So we have this last rectangle, and there we go. Okay, so we already know that delta x, the width of each rectangle, is 1/4, but what we need to figure out are the heights of this rectangle. So again, the height here would be y of 1/4. Here the y would be y of, let's see, y of 1/2. So that's y of 1/2. And then finally we have y of 3/4. Oh, I'm sorry, we're forgetting this one, right? So the most important one, the highest rectangle that we have, is y of 1. So again, if I want to calculate the area, what I need to do is find the area of the first rectangle there, and that's simply just y of 1/4 times delta x. And then we're going to go ahead and add. So we're going to add the area of the second rectangle. And again, the area of the second rectangle would just be this, the height would be y of 1/2 times delta x. And then if we just keep doing this same thing, I know it's a little tedious, but we can go ahead and do this. This is not too bad to do. We have y of 3/4 times delta x, and then finally we have plus y of 1. So y of 1 times delta x. And notice again that they all have a delta x in common. And that's okay because here delta x is of equal width. Every single delta x that we're talking about is 1/4. So we can actually factor out a delta x, and I'll go ahead and do that. I'll go ahead and do that over here. So, well, let me actually just factor out a delta x on this side. And if I do that, I would be left with, let's say, y of 1/4 plus y of 1/2 plus y and 3/4, and then plus y of 1. So plus y of 1. All right, so we have our formula for the approximation here, and I guess I'll go ahead and show it. That's fine. I have some time on the clock. So again, my delta x, I'm going to start plugging in everything that I have here. My delta x is 1/4. Y of 1/4, well, remember we're plugging in to our function here, x squared, so it'll be 1 over 16 plus, if I plug in 1/2, I will get 1/2 squared is 1/4. If I plug in 3/4, I should get 9 over 16 plus, and if I plug in 1, well, that's nice, 1 squared is just 1. So I have all these values here, and I'm going to leave it up to you to calculate this, but if you do run the calculation, you should get 15 over 32, which is equal to, and I have the decimal right here, which is equal to 0.4646875. So go ahead and verify that. And that's it. That's the approximation underneath, or I shouldn't really say underneath the curve, because again we're including some area above the curve, but this would be an approximation of this area underneath the curve. So again, if we compare this value to the previous one, and I have it saved here. So the previous value that we got when we did the left side was 0.21875, and that makes sense because again we're under approximating here, so we know that the area is going to be bigger than 0.2875. But now that we have the right hand approximation, we can now say, well, look, these all over approximate the area. So we know that the true area is now in between 2 point, what did we say earlier? 2.1875 and I'm sorry, 0.46875. So we can kind of think about it like this. We can say that the exact area is going to be between these two numbers here. It's going to be between L4, which was the left-hand sum, and R4, right? And I should have called this R4 from the beginning. So this right here is the right-hand sum with four sub-intervals. And so we can kind of see that the exact area is going to be between, what do we have those decimals at again? We had it between, let's see, 0.21875 and 0.46875. And you might be thinking, well, great, now what if we take the average of them? So if we take the average of them and you add this guy plus this guy, then we get an average. The average area would be 34375. So go ahead and verify that and see if you get this, but this would be the average between the left and the right. And in the next video we're going to go ahead and do the same calculation, but now instead of the right hand and instead of the left hand, we're going to do the midpoint. And the midpoint would look something like this. It would look like instead of getting the left and the right, I now work in the middle, and I use this as a rectangle. And you might be thinking, well, you might have the assumption that this area using the midpoint is going to be this guy here. And so stay tuned and watch the next video so that you can actually see if using the midpoints will give you the average between the left and the right. And you'd be surprised on the result that we're going to get.